remember this. This is easy.
Okay. So I want to simplify that. If you want a title for this, it would be Simplify Radicals.
I remember this. We did this on the summer too.
Alright. So, always just do the number first. So in my answer, right, I'm just going to go ahead and start I always start my answer down here and do one part at a time. Is what I do. Alright. So I'm going to have a square root in my answer, maybe not. But I'm going to go ahead and put one there just in case. So what I need to do first, can everybody see this pointer?
Yes.
Anybody not see the pointer? It just keeps me from having to walk all the way up to the board in case I want to walk back there and make sure somebody's awake or something. Okay. Alright. So I want to start with my number first. So I want to break down 81. What's the square root of 81? It's just 9. Alright. So is anybody confused where I got the 9 from? Okay. Now here's the next part. This is where the other class, because the way I said it was, alright. The easiest thing to do with letters, first of all, they all have to be multiplication. Like if this was 81x to the third plus y to the fourth, I couldn't do any of this. The only reason I can do this is because it's all multiplication under there. If it was addition, you can't break it up and do that, because addition would mean something else. So, which we're not worried about that right now. But all you can do, since it's all multiplication under there, I can take the square root of 81 and it's fine. So now I need to take the x to the third, and this is the easiest thing to do. Alright, I could break it down and say that's 3 x's. Alright, okay, well, not a 3, there's 3 x's. X, x, x. I have one pair of x's. This is kind of what we did yesterday. Alright, you can do a factor tree. I have one pair of x's, so I have one x out here and one x left over that goes on the inside. But the easiest thing to do, since I'm taking a square root, alright, this is a side note, you don't have to write this down. Alright, there's an x to the, oh man, it didn't show up. There we go. X to the first. Alright, do I have to really write that 1 there? No. So the same thing. Have y'all ever seen a cubed root before? You know what I'm talking about with a cube root? If I write a cube root, there's like a little 3 there. Alright? They only write them with cubes or fourths. So really, even though this is a square root, what would be right there? If this is a cube root and it's a 3, square root squared would be 2. So there's really like an imaginary 2 there. It works the same way as the exponent does. It's not there. So there's really a 2 there. So I can, the easiest thing, the reason I'm telling you that is because we're going to use this number for variables. So I'm going to erase that. So whatever we're using, so I'm finding the square root. So I can divide the exponent of x by 2. If it was a cube root, I'd divide by 3. If it was a fourth root, I'd divide by 4, so on. Alright, so I want to divide 3 by 2. Alright, how many times will 2 go into 3? 1. So that's why I have 1x on the outside. Right here. What's my remainder when I divide 3 by 2? 1. So I have 1x on the inside. Alright, so if I had 4, so my exponent for y is 4. So here's y. Alright, so 4 divided by 2 is what? 2. So I'm going to have y, that's going to be my exponent for y squared. And what's my remainder? So I don't have anything else on the inside. So that's my answer.
This is easy.
Okay. Does everybody have this wrote down?
Yes.
Before I go to the next. Alright. Okay. So on this one, I'm going to give you a couple minutes to try to do this one by yourself. What I want, so you're going to have an answer. It's going to have a square root, right? Since this negative 2 is already there, it's going to be there. So then whatever else you pull out from this 48 and the A and the B and the C is just going to keep going there with the negative 2, and you'll multiply all that together. So y'all take a couple minutes and see if y'all can do that. Alright, so let's do this example. Alright, what does the 48 break into?
6 and 4. No, I'm sorry. That's what we're doing right there.
8 and 6. Alright, then I can break 8. Alright, because I want you to get used to this. Any 8 I can break down into 3 2s. I want y'all to, because that's pretty common. You need to be able to see that. So I have one pair of 2s, another pair of 2s. So I'm going to have 2 2s outside there. Alright, then I got a 3 left over, so it's going to go inside the radical. Is anybody confused on what I did there? This method is the easiest way that I know how to do it without, because it works. Because otherwise you're trying to sit there and try to figure out what'll go into 48, right? Because unless you know, of course, 16 times 3 is 48, 16 times 4 is 64. Those are another common like multiplication tables that you need to know. Very common, helps you on the ACT if you know those things. Anyway, because 4 cubed 64. Anyway, so does anybody got any questions on where those come from? The 2 2s or the 3? Right. Then the letters part is really easy. Because this is a square root, so I can divide each power by 2. 3 divided by 2 is 1, so I got 1A. No, I don't think I'm right. Yeah, that's right. And then I got a remainder of 1. I got another, so a remainder of 1, I got an A on the inside. B, the exponent for B is 4. 4 divided by 2, so I have B squared. No remainder, so there's no B's on the inside. C, 5 divided by 2, C squared, and I have a C on the inside. Then the only thing left to do is multiply 2 times 2 times 2, which is negative 8, because there's negative 2, and then A, B squared, C squared, 3AC. Yeah. Alright. So has anybody got any questions on where any of that comes from? We all good? Is everybody good? Alright. So let's try another one. Let's see. Do what?
I'm gonna throw up.
Okay. I want y'all to try this one on your own for a second. Now it's a cube root. It's not a square root. So I want y'all to see if y'all can do that on your own for a second. Thank you. 9 and 9. And then my 9s were sloppy the first time anyway. Not that any of it's really neat, but, it's neater this way.
Could be better.
Yeah. Anyway, so since it's a cube root, instead of trying to pull out a pair of 3s, I need to have a set of 3.
Ooh, so I did it right, buddy.
So if I have I need a set of 3 because it's a cube root. So I have one set of 3, so I'll pull out 1 3 on the outside. Then I have 1 3 left over. So that's going to go on the inside of a cube root. Then I got to do my x's. Instead of dividing by 2, I'm going to divide by 3. So 6 divided by 3. 2. So it's still going to be x squared. Then 7 divided by 3.
Y to the second power, and then y on the inside.
Y on the inside.
I did it right.
I got it
So,
right.
and then you could multiply that, and it'd be -9 in front if you wanted to, plus all that stuff. Alright. So, and I prefer you to multiply that stuff out, because on the ACT it's going to be like that. So, does anybody have any questions? Do what?
So we have to include that little three.
Not no more. So you do have more questions?
Yeah.
It's a double negative. This is not English class, but I'm going to try to correct you. Just it really got on my nerves when people corrected my grammar. I'm going to pause.
He's recording.
Yeah, that's fine.
We'll be all up on that.
Are they famous because of the
Because of corn.
because of corn? Yeah.
Are you kidding? Cornbread, cheese, 5.
You're really being on my difficult bro.
Do what?
He is not your bro. Yeah, ain't good with that one yet.
Side of me.
Alright, so I want y'all to try this one on your own for just a couple of minutes.
Add that Z.
Alright, here we go. Let's go over this one. So first I've got to break down 128. What can I break that down into?
2 and 64.
2 and 64.
2 and 64.
8 and 8. And then 3 2.
Well, that works.
Alright. So really, 128 is 2 to the 7th, by the way. That's why I was telling you it's a unique. 128 is 2 to the 7th. Then, like, 2 to the 10th is 1,024. 2 to the...
Is it like that game? 2048. You know that game?
No.
You don't know that game?
Yeah.
Alright, so instead of a pair of 2s or a set of 3, I need a set of what?
Can't believe you don't know what that game is.
So in order to pull something out, I need a set of 5. Alright, then I've got 2 2s left over. So I've got my 5th root. And then I can pull one, so I still got this -5 out here. I got one set of 5, so I can pull out 1 2.
Wait, there's
And then I can do a negative, not negative. I got 2 2s on the. So I want to have 2 2s on the inside, but so I go ahead and multiply them together. It's going to be 4. All right. Does anybody confused on where I got the 4 from? All right. So now I just got to go through and divide each of these by what? So 10 divided by 5.
2.
X squared. Then y to the 12th. All right. 12 divided by.
Outside, 2 on the inside.
2 inside, 2 outside.
And then z to the 7th.
1 outside, 2 inside.
Alright. And then if I want to, I could change that to -10 out front. Does anybody have any questions on any of this? Why did I do what?
Why do you put first on the outside?
Y to the what? That's a 2.
But Z, but the Z. Not the
You don't
Y.
have to write the
Z.
1. You don't have to write the 1.
But why did you put that Z to the Z on the inside?
Alright, because I divide 7 by 5.
Okay.
5 goes into 7 one time, so that's why it's z first.
Oh,
The
and then you put
remainder-
The remainder
the
inside
remainder.
the root.
Yeah.
Oh, okay.
The remainder goes on the inside of the root.
So pretty much what we do is
That's
Yeah.
why it's sitting there.
You divide it by whatever that is. So if it was a 6th root, you divide by 6, or a 10th root, you divide by 10, or whatever it is.
Ow.
If it doesn't go in there at all, then you can't take it out
Crusty.
of anything. Does everyone have this one written down?
How many more examples do we have?
What is that
May I
negative
say
unit?
what?
Oh, just kidding.
We're gonna do one more
Don't forget the pause.
that I'm gonna make up off the top of my head.
Really? Oh yeah, it is. It is 5.
It's in my goodie bag. And I gave them
All right, so let's do.
I know we did so much work, but that doesn't mean that it's.
I know I
We
am.
did
I'm
all
like the
that.
best section leader in the entire company. Yeah. You're telling me they wouldn't have the biggest mouth in this entire room.
Two, four, three.
Next year I'm gonna be
Actually, everyone told me in class.
What?
I got a question.
I'm marching next year. I ain't doing that.
Yeah.
I'm tired of it. I'm tired of drama. I'm tired of work.
Is that like 21?
Yeah.
Bro, shrink the numbers.
For real.
C's gonna have. All right.
That's not what I
There you
meant by
go.
shrink the numbers.
There you go.
Don't forget the pause.
All right.
I got this one.
So, start with. Do what?
I think I got it.
Start with a number.
360. No, I put 81.
Here it is. Actually, this is what I would do. I would pair stuff up. So, like, start with your numbers.
3 and 81.
So, my number on the outside is -7, and then this one, yeah, 81
Three.
and 3. And then I can do that 9, 9, and then 3, 3. So really, 243 is 3 to the 5th. That's why I use 243s, because I wanted you to know 243 is 3 to the 5th. 3 to the 4th is 81. Those are common powers that you... Yes? Okay. I don't know if it's... All I heard was mumbling to start with. I just want to make sure they weren't expecting me to answer that. Alright. So then, it's the 4th power, so I need a set of 4. So I got one set of 4. Alright, I should have wrote this up. Then I've got my 4th root. I have a 3 left over, so I got a 3 on the inside. Alright? Then I'm not going to have enough room right there. So then I got an A. Alright? 31 divided by 4.
That was...
7.
Oh, I had it down. 7 with the remainder of 3. Yeah.
Well,
That's it.
4 times 8 is 32, so 7 with the 7 with the remainder of 3. So I got 3 on the inside, A to the 7th on the outside.
I got a question.
Yeah.
You add those to the other ones, right? When there's an original problem?
Yeah, I need what's in the original here, so I'd have A squared times A to the 7th. And when I add exponents, what do?
You multiply, you add.
Right, I add them. So it's A to the 9th. So y'all have learned all those rules, right?
Yeah.
Because normally we didn't learn those rules till like Algebra 2.
What?
Well, we learned them a little bit in Algebra 1, but like we didn't really do work with them till Algebra 2 when I was in school. But I'm glad y'all know them because it's less time we have to spend.
We gotta do both like the following year.
Then B, alright, we've already got one B in this problem, and then,
B, no, there'd be
So
5,
this
1
is-
left over.
Yeah.
Six of that.
so I'd have B to the 5th, and then B times B to the 5th would be B to the 6th. Alright. And then, I have one left over.
Oh yeah, I forgot.
And then C to the 3rd. Will 4 go into 3?
No.
No, so just, alright, it's supposed to be C.
We did it.
C to the 3rd. So,
3.
square, or
That 3
4th
looks like
root.
this.
I got a halfway wrong.
Right, so does anybody got any questions on any of this stuff?
Nope, got this.
Are we good?
Yeah, this
We
is
square?
good.
Are you stretching?
This is
Alright.
really